Okay, good morning once again. Let's open the file that we were working on yesterday. So this is the Arima model class. So we're going to continue our discussion of time series modeling. We said that we know what a time series is. We defined that yesterday. Okay, make sure that the packages, by the way, are already acquired. Okay, check ko lang kung naran ko na. Okay, so we said that time series analysis, it's both a science and an art. No? Kasi what we want to do is to extract useful insights about our data. And not only that, if needed, we would like to forecast. So pwede natin i-forecast yung time series natin. Kasi that's a usual activity done. And lalo na guys dito sa library na to, itong forecast package, this is a very powerful package. Maraming capabilities, no? And we said there are many methods, there are many models that we can use in time series, but we will be focusing on just one, yung Box-Jenkins approach, which is popularly called yung Arima modeling. So sa Arima modeling, we said yesterday, you have the AR component and the MA component. The AR is autoregressive, which means that we model the time series based on past values of itself. And then sa MA, it's based on the error terms of the model. Okay, so yesterday we learned, for example, that an AR1 model is written as, ito sa ilalim na to, AR1, so you have the series Y sub t. Y sub t is equal to a certain constant, it's the intercept, plus Y sub t minus 1, so this is the past value of Y sub t, multiplied by a certain coefficient, plus an error term, which is yung error term na to guys, yung E sub t, this is what we call white noise. White noise. Ang ibig sabihin ng white noise guys, it's a stationary data that whose mean is equal to 0. So pag ang mean niya equal to 0, it's what we call a Gaussian, kasi yung Gaussian, di ba? So pag white noise guys, hindi na pwedeng i-model yan. Okay, anong difference sa AR process? Ang AR, you can model it, no? Ang white noise, hindi na pwedeng i-model yan. Wala nang zero na yung mga autocorrelation niya. Then we have a special type of, kapag 1, 2 guys, we call it a random walk. We'll talk about that later. No? So kapag order 2, yung AR natin, yung AR process, autoregressive process natin, you have, your predictors are the past 2 values, Y sub t minus 1 and Y sub t minus 2. In general, we call it ARP, order P. So there are P lag values, no? Lag values of itself. So hanggang Y sub t minus 1, Y sub t minus 2, hanggang Y sub t minus P, hanggang yung sa, tama ba ito? Y sub P. Okay, plus an error term. On the other hand naman guys, ano yung MA natin? Alala niyo yung MA, sinabi natin. Pag MA, Y sub t is equal to, so you have your error term, E sub t plus, you have, let's call it B1 times E sub t minus 1. Okay? MA1 yon. So we are modeling the time series based on past error terms. Okay, so yun yung MA. so yung MA, yung Q guys, it means Q past values of itself. Okay, so it's denoted as Arima PQ, yung P denotes yung AR component, yung Q denotes the MA component. So what's Arima 11? Ano yung Arima 11, guys? So y sub t is equal to, okay, so may AR component muna tayo, no? Ano yung AR component natin? That will be yung intercept natin, A sub O, okay, plus A1 times y sub t minus 1, okay, that's the AR1 component, plus you have your A sub t plus B1.
Sir?
Yes?
You're not screen sharing po.
Ay!
Thank you, sir.
Grabe.
It's okay,
sorry.
sir.
Sorry,
It's okay.
buti. Wala naman sa inyo nagsasalita.
Yes, sir. I wasn't sure if I should bring it up.
Okay. Imagine kung buong period hindi pala ako naka-share screen. Thank you for informing me.
No problem, sir.
Sorry. Ayan yan. Naku, ang dami ko nang na-discuss Okay. So, sorry about that, guys. Okay, so just a quick review, guys. Sabi natin ng AR1 process, we are regressing your time series. Okay, I'm using regression. Kasi regression din naman to kasi linear model to, no? We are modeling your time series based on its past value. So why din siya pero t minus 1, yung previous value. Okay, so AR2 will be the two past values, no? Y sub t minus 1 and y sub t minus 2. Yung MA naman will be the past error terms. Y sub t is equal to error term plus b sub 1 times the previous error term. Okay, so yung order ng AR process, it's denoted by P. Yung order ng MA process, it's denoted by Q. Okay, so ang Arima 11 will be, yung series natin, yung time series will be modeled equal to a certain constant plus A1, okay, times the y sub t minus 1 component, yung past value niya, kasi AR1 to, no? Plus yung MA process niya, yung E sub t minus 1, so that's B1 times E sub t minus 1. Alright? Okay, when you have Arima ngayon, ibig sabihin, itong D na to, D refers to difference. Ibig sabihin, guys, bago natin bago natin minodel, dinifference muna natin data natin. If you recall yesterday, guys, sabi natin, you need to do differencing if the data has what? Has a trend, di ba? Pag may trend yung data, hindi siya stationary, ang unang transformation na ginagawa diyan, dinidifference siya. Kasi by differencing, you are treating the you are addressing the problem of trending. Well, not problem, but the issue of trending as regards modeling it. Sabi natin kasi pag may trend, hindi natin magagamit yung Box-Jenkins approach. We have to convert the data, the time series, into a stationary time series. And what is stationary time series, guys? Sabi natin, no trend, okay? And no constant yung variance. Okay? So if our data is not displaying that, then we will have to transform our data. So check if it's stationary. If it's not stationary, then we transform the data. If there's a trend, then get the difference. If there's stationarity, no? Pag ano yung data kapag may seasonality pala, sorry. Ibig sabihin hindi ko I'd like to correct myself. Kapag kasi may seasonality, pwede rin namang may seasonality na walang trend, no? So ibig sabihin, ano lang siya, constant yung mean natin, pero may seasonality siya. Pwede rin naman, guys, may seasonality na may trend. So there are several combinations which we showed yesterday, no? Okay, so ang bottom line, guys, kailangan bago natin ma-model, kailangan maging stationary muna, and then that can be and then pag stationary na, pwede nating i-drawing yung ACF at saka PACF. Okay? When we draw the ACF and the PACF, then that will allow us to determine kung anong klaseng Arima or Arima model yung gagamitin natin. Okay? Alright. Pag yung data guys hindi pa stationary, tapos pag plinat natin yung ACF at saka PACF, makikita din natin guys na hindi pa talaga stationary yung data based on the ACF and the PACF. Okay, I think it's better for us to now go to, kasi na-discuss natin to, yung mga examples yesterday. Okay, so balikan lang natin itong example natin, di ba? Itong data natin yung air passengers. Let's have a quick review of that. Andito pa ba siya? Or na-close ko na? Is it still here? Na-close ko na yata. Anyway, so let me just run this. Data at saka yung, I'll call it AP na lang. Okay, then of course, sabi natin, dapat pinaplot natin yung data natin. Ito yung plot niya, no? This is the plot of our time series. Okay. Quick question guys, stationary ba yung data natin? Answer?
No, sir.
No, of course not. Kasi may trend siya. Tapos may ano pa, may hindi constant yung variance, di ba? If you draw a line, hindi constant yung variance siya. May trend, may seasonality. Okay, so hindi stationary 'yon. Of course, may yung tapos yung ano niya, yung seasonality niya, it's multiplicative, no? Anong klaseng seasonality niya? Multiplicative kasi nag-i-increase yung yung band ng variation niya across time. So this is an example where we cannot use the Box-Jenkins approach here. Of course, pwede din natin itong ma-forecast or ma-model using a different approach. Maraming klaseng approach kasi may exponential smoothing, etc. But yung focus natin dito kasi madali yung mas madali yung Arima, no? Mas madaling mag-modeling ng ganun. That's why we're learning that. Okay. All right. So okay, plot natin. Okay. We also learned how to decompose our data yesterday, di ba? Dinecompose natin siya. Sabi natin, pag dinecompose natin, makikita natin yung trend. Okay, so I'm waiting for it to run. We can see here the trend, the seasonality, and the irregular component. Yung irregular component, guys, ito yung hindi kasama sa trend, hindi kasama sa sa seasonality. No? So this is our data. So we can see here that ito yung trend niya. Okay? Tapos ito yung seasonality. Then this is the remainder. Okay? So when you add all these three components, yun yung data natin. Okay. All right. Then sabi natin, visually pwede natin malaman kung hindi stationary. Very obvious naman. But we can do a statistical test. Sabi natin, ang ginamit natin dyan yung ADF test, yung Augmented Dickey-Fuller. Okay? And that comes from the package T series. Okay? Ano yung dito? Ano yung null hypothesis? That the time series is not stationary. So when we run this Dickey-Fuller test, p-value is 0.7807, okay? And that means that we fail to reject the null hypothesis. We fail to reject this one, that the time series is not stationary. Okay, so statistically sinasabi sa atin na not stationary nga talaga yung time series natin. Okay, so yesterday we learned how to plot yung ACF at saka PACF. I'm going to teach you an easier way to plot yung ACF. Kasi yung ACF at saka PACF, let's just check the yung autocorrelation function. Ginagamit yung ACF at saka PACF to determine if number one, kung stationary ba yung data series. Number two, ginagamit din siya to approximate or to come up with a model kung AR ba siya o MA ba siya. Okay? Pangatlo, ginagamit din yan para matest natin kung nag-model na tayo and if our residuals are already okay, are white noise na. So yung ACF natin, it's from the package stats. There is another function, mamaya gagamitin natin ito, yung autocorrelation. Okay, and it's from TSM. No? It's from the TSM package. So mamaya natin to i-load. Okay, while I'm talking guys, sandali. Okay, I actually prepared another notes, no? Share ko lang to guys, tapos i-load nyo na rin, no? Sa chat. Just take note of the yung codes kasi minsan pag kinopy natin yung codes na yan sa okay, so just copy that guys kasi ipapa-load ko sa inyo yan, papa-install, no? Kasi yung library yung TSM kasi doon makukuha yung AC yung autocorrelation function. It's a very powerful function. Okay? Kasi unlike yung ACF at saka PACF, hinihiwalay pa natin siya. Yung AC, you can already get both of the ACF at saka PACF. Okay, tinatest ko lang, wala dito yung yung TSM. Yung mga dito. Okay, so ito example mo guys. No? Okay, let's go here. Okay, yesterday we were working on this. Dito tayo nagtapos, di ba? Dito baka kahapon guys. Saan ba tayo? Anong line tayo?
Sir, I get an error po when I call the library TSM.
You will have to load first yung in-install mo na ba? Install that packages?
I tried looking for the package po, I couldn't find it.
Ito na lang. Yan, nasa development tool siguro yan. Nasa yan. Ito. Yung sinend ko ngayon, guys, ito, yung DevTools installs via GitHub. No? Kay Kevin Kodzi kasi itong TSM. So install niyo muna to guys yung first two. Make sure that naka-install na yung DevTools na package. I didn't anymore install this kasi na-install ko na siya. Nag-work na ba?
I'll install DevTools first, sir.
Okay, sige. Thanks, Pao.
Thank you, sir.
Sige. So while you're installing, paki-feedback Pao kung kung okay siya. Okay, ito guys, wag kayong magugulat sa na to ha. This is just a loop formula to generate MA models, no? Simplify muna natin. I think I made a mistake in coming up with a complicated model immediately. Okay, so ganito gawin natin guys. I'm at, andito tayo, no? Here, you're generating an Arima model. Okay, mag-insert na lang tayo dito ng mas simple. No? Or, better still, sige, dito na lang. Okay, I'll just first, let's first simulate. No? Magsa-simulate tayo. Gagamitin natin, guys, yung auto.arima na function. Sorry. Arima.simulate. Arima.sim. Okay, tingnan natin, guys. Yan, no? It's from the stats package, no? So just for you to be, para alam nyo, sa stats package yan. Okay, so what does it do? It simulates an Arima model. Tapos ito yung ano niya, ito yung yung syntax niya, yung model, yung N, okay, etc. So let's try to simulate an Arima model. Okay, take note, guys, nag-add na tayo ng code na lang dito. So let's use that. Let's create an object called A1. A1 and then, oops. Wala, natago lahat. Paano nga pala yung code dito? Wala. Ano ba yung view? Nasa view ba siya? View. And then,
Sir,
yes.
there were problems when I installed the DevTools. There were
Nagka-problems.
several warnings, and then I tried running the autocorrelation codes you sent. There are also warnings. I don't think it ran correctly.
Sige. Let's see na lang muna, ha? Okay, thank you for informing me, ha?
Yes, sir.
Okay. Kalimutan ko yung function dito para kasi nag-hide yung mga yung mga nag-hide yung mga chunks. Paano nga ba yun? Expand. Not this one. Expand all out. Code. I forgot. I pressed something tapos na-minimize yung mga code chunk. Tapos, diba? Okay, never mind. Ano ko lang siya maximize as we go on. So where are we? Nakaka-distract yung na-minimize lahat ng ng code chunk. Okay. So let's simulate, guys. What's this? Oh boy. Hindi ko na nakikita yung ano eh. Anyway, sige. So let's create an object called A1. And then we're going to use Arima.simulate. No? So this is the Arima simulate. So we're going to ask R to create a model for us. Yung we'll use, ito yung syntax niya, no? And model. Ano yung model natin? So let's use a model, no? Copy ko na lang yung ginawa ko dito guys para mas mabilis. Kasi I'm going to send this to you. I created another file for you to practice on. Okay, nag-simulate na ako dito. Ano? Ito yung sinasabi ko guys na na AC function. Okay. Sige. Para mabilis tayo. Okay, mag-set.seed tayo guys para pare-pareho tayo ng no? So let's give this a name A1 and let's simulate an Arima model. Tingnan nyo, itong model is equal to list. Ililist natin si AR, autoregressive, no? And then we will generate a model where the AR component, yung A-1, okay? A1, no? Is equal to 0.8. Diba? If you recall, dali, magbukas lang ako ng Word. Okay. Oh. Oh. Gumagana itong okay, so we're using the arima.sim and sabi natin yung model natin y sub t is equal to a certain constant plus a1 times y sub t minus 1. Okay? Right, then ang ginawa natin yung a1, sabi natin, ginawa natin na 0.8. By the way guys, sa Arima model, yung natin, yung A1 natin, okay, it cannot, ang condition yan, dapat yung A1, yung absolute value ng A1 should be less than 1. Okay, in other words, pwede siya maging negative. Okay, pwede siya maging negative, pero dapat less than 1. Pwede siyang positive or negative, but it cannot be greater than 1. Okay? Kasi pag naging greater than 1 na yan, mag-explode na yung model natin. Ibig sabihin, hindi na siya magiging stationary. Okay, so always guys, yung coefficient ng AR1 model natin na E1, it should be less than 1. That's why in our model here, diba, ang ginawa natin, ito, yung AR1 natin, yung A1 natin, it's 0.8. Okay? 0.8 siya. Okay, so let's generate this para pare-pareho tayo ng nag-set.seed tayo. Set.seed 1, 2, 3. Okay, if you run this, okay, so may na tayo, may ito na yung A1 natin, 1,000 data points, okay? 1,000 observations. All right, nag-generate na, no? And then let's plot that. Plot. Gamitin natin si plot.time series. And then A1. Let's see if the model that we generated is a time series. Is not a time series, is stationary. Yan, tingnan nyo guys. Is the model stationary? Is the time series stationary, guys? Chat nga kung answer kung yes or no. Hello, guys. Stationary ba? Unmute na lang ha para mas mabilis tayo. Thank you, Pao. Thank you, Matthew. Yes. Stationary yung na-generate natin na object called A1. Diba? Pinat natin time series there. Okay, it's indeed stationary. No? Okay, let's check, guys. Let's check yung control out. Ay, let's check yung ano niya. Ito yung sinasabi ko sa inyo, no? Yung AC. This is autocorrelation. Pao, pakicheck kung gagana to sa iyo. Our object is A1, di ba? Okay. And then, ilagay natin yung log, maximum log natin. Maximum log is equal to, let's say, 1.5 years, 18. Okay. So, let's see, guys, kung ano mangyayari, anong generate na ACF at saka PACF. Let's run this. Okay, tingnan nyo guys, automatic, no? Automatic na pinakita sa atin yung ACF at saka PACF. Unlike yung sa stats package na iisa-isahin pa natin yung ACF tapos PACF. Dito sa TSM package, no? Autocorrelation na lang, then automatic niya i-generate yung ACF at saka PACF. Okay, so sabi natin guys, yesterday, I think I mentioned to you that yung ACF at saka PACF, okay, this is indicative that this model is stationary nga, no? Stationary siya, and it has the look of an AR process or an MA process. AR process, guys, or MA process? Good. Yan, buti naman Pao na nag-work na. No? Okay, so this is better. Yung AC is better than ipa-plot pa natin yung ACF at saka PACF separate codes. No? Okay, so di ba guys, I think I mentioned to you yesterday, hindi ko talaga nakita yung kung paano na to. Nababother tuloy ako. Saan ba yun? Preview images. Chunk output. I can't see it. Anyway, sige. Tuloy pa rin natin kasi I'm wasting time. Okay, where was I supposed to go? Okay, dito sa part dito, I mentioned to you here that sorry guys, medyo na ayan, ito na ba? Okay, ito alam na natin to guys, no? Yung AR1, which is the same as Arima 100 or ARMA 10. Okay, ito equivalent lang to guys. AR1, Arima 100. Remember, this is PDQ. P is the component of AR process. Q is the component of your MA. And the middle number here is your differencing. Pag kailangan natin mag-differencing, first differencing, magiging 1 yan. So an AR1 process is the same as Arima 100 or an ARMA 10. Ibig sabihin dito, hindi din-difference. No? Okay, so I'm looking for our notes here. Okay, ito. Actually, dito din siya sa ilalim. No? where's the asan na yung notes ko dito about about yung behavior ng ACF at saka PACF. Oh boy. Can you help me, guys?
Sir, I think for me it's around line 520.
520 ba? Ang layo na
Yes,
pala.
determining the Arima model po.
Okay, thank you. Let's see. Natago kasi yung mga I forgot to yung shortcut dito kasi may shortcut to na para lahat yan I pressed something accidentally, so natago lahat ng code chunk. Ngayon, there's also a quick shortcut para matanggal yung yan. Okay, is this the one? Siguro may problema na itong mouse ko. Close ko na nga muna ito para what's happening here? So, nag-freeze yung screen ko Close ko nga ito. Oh boy. Nag-ano yata siya, nag-freeze na. So that's 520 daw. Okay, hindi Anyway, what I was trying to say there is that you can determine what type of time series your data has based on the ACF at saka PACF, no? So how do you do that? Pag AR process, guys, you use the PACF, the partial autocorrelation plot, no? In order to determine if it's an AR process. If it's an AR process, what you can see is that the PACF has a spike, S-P-I-K-E, spike at a certain point. Okay? So nag-spike siya sa a certain point, and then yung sa ACF niya, it's a slow decay. Okay, so balikan ko yung natin kanina dito, yung example. So where was I? Right here. Okay, di ba nag-simulate tayo ng isang AR model where phi1 or A1 is equal to 0.8. Okay? So Arima that simulate, AR component natin, AR1 component natin is 0.8. So pwede yon, guys, kasi sabi natin ang phi1 or A1 dapat less than 1 siya. Okay? Absolute value pwedeng negative 0.8 yan, or pwedeng tingnan nyo, lagyan natin kunyari ng negative 0.8. If I made this negative 0.8, and then if I run this, okay, tanggalin ko na siguro itong view, no? Para hindi na natin tingnan. Ito na lang importante, yung plot. Yan. So that's negative 0.8 yung coefficient niya. So pwede, di ba? Pwedeng negative, pwedeng positive for as long as it's less than 1. Now, if we put here 1.2, no? 1.2. Subukan nyo nga i-run yan, guys. Let's run this. Okay, sabi error daw, no? Error daw. Because kapag 1 na yan, guys, 1.2 na yung A1 component natin ng AR1 process, hindi na stationary yan. Sabi ko nga, mag-explode na yung, yung series natin. Magkaka-trend na yan o hindi na siya magiging stationary. So for an AR1 component, dapat yung A1 natin or phi1, kasi sa iba ang ginagamit na lang formula, just for you to, para pag kunyari nagbabasa kayo ng something about that, yung iba ginagamit nila na y sub t is equal to a naught plus phi1 y sub t minus 1 plus epsilon sub t. Okay, tapos yung naman nila, yung MA model y sub t is equal to a null plus theta 1 epsilon t minus 1 plus epsilon sub t. Okay, error terms, no? So this is the MA model. Ang ginagamit minsan yung theta 1. Okay, so balikan tayo dito, no? All right. Now take a look at the yung AC function. Okay, ito. Take a look at that. So what's the characteristic of the ACF and the PACF? Sa ACF niya, slow decay, no? Slow decay. It decays over time, ganyan. Tapos sa PACF niya, there's a spike. May spike siya and then hindi na significant, no? So this is indicative of an AR model. Arima model, AR model, autoregressive model. Okay? So we use the PACF to determine kung anong order ng AR. Okay, so this is a spike at 1, no? At the first log. Ibig sabihin nito, AR1 process to. Okay, tapos dito sa ACF, slow decay siya. Pag MA model, guys, baliktad, no? Pag MA model, ang ginagamit natin na basis yung ACF. So may spike dapat dito sa ACF, pwede ang spike isa, dalawa. Pag dalawa yung significant spike niya, it's an indication that MA2 model yon. Okay, so titingnan natin kung saan significant yung spike. So again guys, sa MA model, what we use is the autocorrelation function. Okay? Sige, gumawa din tayo ng ng MA. Sige. So let's do that, guys, here. I'm going to insert another code here. Okay. So gamitan na lang natin din to. Control C. Control D. Let's call it M1. And dito, MA, no? Moving average is equal to, gawin natin 0.6 kunyari, no? 0.6, 1,000, and then huwag na natin i-view. Plot na lang. Okay, so let's run this. Para pare-pareho tayo, guys. Let's run this. We would have generated the same data. Okay. Take note, guys, that ito, no? Stationary siya. So okay yung series natin, yung M1. It's stationary. Of course, just by looking at it, hindi natin malalaman yan kung AR yan o MA yan. You will be able to know, guys, kung AR yan o MA by looking at the autocorrelation function. So let's copy this. AC. Okay. AC. And then M1. So let's plot yung autocorrelation function natin. Enter. Okay. What do you notice, guys? What do you notice? This is an MA, MA series kasi nag-spike siya sa spike siya sa 1, no? Sa log 1. And then wala na dito, no? Tapos slow decay siya dito. Both positive, negative. Slow decay siya sa PACF. So that's an indication that this is an MA process. Okay. Any questions, guys, so far? Any questions ba? Clear yung ginagawa natin? I wanted to show this to you para clear sa atin kung paano natin malalaman using the ACF and the PACF kung ano ba siya, kung AR process or MA process. Okay, sige, tingnan natin guys kung what if it's ano. Kukopyahin ko na lang dito guys para mas mabilis tayo. Okay, dito nag-test din ako. Ibibigay ko sa inyo to guys ha, with the notes on it. Okay, dito dito tinetest natin yung ano no. Pinatest ko dito yung hindi ko pa lang kasi natapos eh kaya dapat na share ko na sa inyo to. Ayan, ito. I'm going to copy this guys. Sige, copy natin to no. Control C. Ay sorry. Control V. So, ilagay ko sa chat para mas mabilis para hindi na kayo masyadong mag Ayan. Okay? So here we're creating an object called X and then we're simulating an Arima model is equal to hindi, wait. Sorry. Ang nakopy ko dapat yung ano. Okay. AR lang yung nag-send ko sa inyo, no? Ito, nag-send ulit ako guys ng ano ng Arima. Okay. So this is an Arima 1.1 process guys kasi may AR component tayo. AR 1.4, MA is 0.5. Okay, so dagdagan din natin yung ano yung sample natin. So this is an Arima 1.1 process. Okay, so i-plot natin si X tapos kunin natin yung hanggang dito muna sa plot para makita natin yung series. Yan, okay? So indeed guys, this is a stationary series, no? Yung na-generate natin na object based on simulating an Arima process. And then let's plot the autocorrelation. Okay, so what do you notice about guys the autocorrelation function for an Arima process? What do you notice? Anyone, guys? So you notice guys that ano siya parang slow decay siya sa pareho, no? So signal yun guys kapag slow decay sa ACF at saka sa PACF. Okay? So it's a signal that it could be an Arima process, no? So yun ang difference. When you look at the ACF, when you use the ACF in order to if the ACF has a spike at L logs, kung ilan man logs yun, tapos slow decay siya sa PACF, then it's indicative that it's an MA process. Okay, ito. Spike dito, tapos slow decay siya sa PACF. On the other hand naman, spike, yung PACF, may spike siya, depende kung anong log, pwedeng spike at 2 logs or 3, depende sa series natin, and then slow decay dito sa ACF. So that's indicative of AR process. Ngayon, before, ang ginagawa namin, guys, nagmo-model kami. Sinusubukan namin AR1, MA1, Arima 1.1, AR2, MA2, etc. No? So, padamihan, no? And then, ang ginagawa, guys, dinidetermine kung ano yung pinakamaliit na AIC, yung Akaike Information Criterion. So medyo manual dati yung approach. Now, hindi na ganun, no? Okay, so let's go back here a bit. Let's see, guys, i-model natin to ngayon, itong AR na to. Parang nagre-reverse engineering tayo. Nag-create tayo ng data, ulitin ko lang nag-create tayo ng data A1, no? Di ba? Ito yon. Sinimulate natin sa Arima. So we have this object called A1, and then we looked at the autocorrelation function, okay, ACF, and the partial autocorrelation function. This gives us a hint that this is an AR process. Okay? Assuming na hindi natin talaga alam na ano to. So parang hindi natin inassume natin na hindi natin ginawa tong ano, hindi natin alam na AR1 talaga to. Let's use now the function of Arima, no? Okay, so let me just copyin ko lang dito para mabilis, para ma-share ko na kagad sa inyo. Okay, dito. I should have sent this to you, kaso hindi ko pa tapos gawin to, no? Sabi, okay. Tinest ko na to eh. Dili ah. Okay, ito. Okay. Control V. Okay. Paki-copy nga yan guys, under the ano, under our platform. Okay, what are we doing here, guys? Okay, dito guys, kasi yung PACF nga, no, nakita natin na PACF has a spike at 1, tapos slow decay dito sa ACF. Then, ang educated guess natin dito, baka AR1 process to. No? Kasi pag may dalawang spike sa 1 and 2, so ang indicative yun na baka AR2 process. So now, we're going to create an object called Arima10. Ibig sabihin, AR1 to kasi wala yung MA na component. Then we're going to use Arima. Yung Arima. No? Arima, tapos let's test. Minomodel natin guys, nag-create tayo ng model A1. Okay? Tapos sabi natin ng order is equal to C100. No? Ano yung 100? AR1 component, 0 differencing, 0 din yung MA. Then include that means equal to false. So dito ginagamit natin yung specification ng Arima, PDQ, no? Where P is 1, differencing is 0, and Q is 0. Okay, so let's see guys, ano yung naging model natin ito. Run natin to. Okay. Negative ko to, no? Ay, nawala dito. Ano ba yung huli ko dito, guys, diba? Negative 0.8 ba? Gawin ko na lang 0.8 ulit. Kasi pinalitan ko ng negative 0.8. I-run ko ulit. Ginawa ko ulit 0.8. Tapos i-run ko ulit to. Yan. Talagang ano, no? Talagang spike niya at ano? Spike niya at log 1. Tapos slow decay. Sabi natin indicative of an AR1 process yan. So i-run ko ulit to. So minomodel ko siya, no? Okay, what do you see guys? So sabi ko kay ano, sabi natin kay R, mag-create nga siya ng ano, i-model niya, come up with a model for our time series na A1. Okay, so nag-guess tayo na ano siya, no, na nag-guess tayo na ano siya na 100. Okay? So ang linabas niya, guys, na ang coefficient ng AR1 component niya is 0.8212. Okay? Diba? So close, malapit guys, no? Kasi ang simulated model natin ng AR component natin 0.8. Since ano lang to, yung random ano lang to, no? Simulation lang to, no? Okay, so did you also get 0.8212 guys here? Hello? Still there, guys?
Oh yes, sir. I'm still copying the code.
Sorry?
I'm still copying the codes here.
Okay. Sorry. I think I'm going too fast. Guys, pakisabihan ako pag masyado akong mabilis, no? Pakisabing break muna. Minsan nakakalimutan ko na wala pa tayo sa classroom.
Sir, is it okay if you scroll up a bit po? I just
Up.
want to check something po.
Here?
The other way po, sorry.
The other way, sorry.
Yeah, thank you po.
Okay. I'll give you a few minutes, guys, to work on it. Yeah, yeah, okay lang yung Matthew kasi yung baka yung pangalawa hindi ko na set that seed eh. So but it's very close yung answer mo, no? I think hindi ko na rin yung set that seed nung kaya we'll be having different answers, no? So that's okay. But what it's telling us is that medyo close yung no? Medyo close yung model natin, very close to the initial na ginawa natin na 0.8. Right?
Yes, sir.
Mm-hmm. So ibig sabihin okay yung modeling natin, no? Okay, so everyone nakasunod ba? May questions, guys? Okay, so I got 0.82. So it means that our model is A sub O plus, hindi pa binigay yung, check ko Okay, let's first tingnan muna natin, guys, yung ano ba yung laman ng names ng Arima 10. What's inside here? Okay, yan ayun yung mga coefficient, yung AIC niya, okay, yung variance coefficient, etc. So there are so may residuals din, no? May residuals. Tingnan natin, guys, yung plot ng residuals ni Arima 10 model natin. Dapat kasi, guys, yung residuals dapat white noise dapat yan, no? So let's see. I-plot natin, let's plot Arima 10 and then yung residuals. Okay? So here I'm telling R to plot from the object Arima 10 yung residuals. Let's see. Kung ano yung plot niya, yun. So we can see that okay yung residuals natin kasi wala namang walang trend, walang heteroscedasticity. So it's just random talaga na And what we can do is control 1, AC natin, okay? Yung Arima 10 residuals. Max. Okay, let's get also the autocorrelation ng yung residuals, ha. Yung residuals. Pause sa'yo, 0.76. Okay. Magkaiba-iba tayo kasi mukhang baka riniran nyo yung model tapos hindi nyo sinama ulit yung set.c. Ganun din nangyari sa akin. No? I didn't include the set.c. But if we had run it na sinet.c natin, pare-pareho tayo niyan. Okay, but hindi pa siya nag-run. Okay. Arma 10. Arma 10. Okay. What do you notice, guys, about the residuals? What do you notice about the residuals of your Arma 10 model? Anyone? Yes, correct. Thank you, Masahiko. No spikes na. No? And this is what you call your white noise. So dapat yung error terms natin, guys, yung residuals natin ng model natin, dapat ganito. Dapat ganito. It should be white noise. Okay? Pwede ba, guys, na pwede ba na nagmo-model tayo tapos either kunyari nag-arma tayo tapos nung chinek natin yung residuals, may mga spikes pa rin. Okay? That's possible, guys. When will that happen? That will happen when when there's a great volatility sa time series natin. Okay? Ano siya, stationary in mean, pero sa variance medyo may mga points na may mga points siya na very volatile, no? So may mga points lang, may some in your time series may mga points siya na volatile. Pag ganun, guys, pag ganun yung nangyayari, baka hindi na pwede yung Arima model doon. So we will go now, next meeting, pupunta na tayo ngayon sa improvement ng Arima na kayang i-model yung Arma process natin at saka yung volatility. And that's what we call, guys, yung Garch process. Garch. So dito tayo papunta, guys, next meeting, no, Garch, which is generalized autoregressive conditional heteroscedasticity. Take note, autoregressive pa rin siya, no? Pero sinasama natin yung pag-model ng volatility, yung conditional heteroscedasticity. Okay? So when you have a time series where the volatility is not constant, no? So usually ganyan yung sa mga stock returns. Kasi may mga times na talagang matataas yung persistent tumataas, tapos minsan naman may persistent na bumababa. Okay, yun dun sa mga points yun, guys, nagkakaroon tayo ng heteroscedasticity. So we can't use the Arima model for that. We will be using the Garch model, generalized autoregressive conditional heteroscedasticity. Okay, guys? Clear so far?
Yes po.
Okay, so at least now alam nyo na, guys, alam nyo na kung paano mag-determine. Ito, tingnan natin to, no? Itong Arma model natin. Okay. So dito sabi natin mukhang Arma model siya, no? Parang parang 3, no? Tatlong spikes sa PACF, no? Tapos sa naman, parang dito naman parang 3 din yung 3 din or 2 yung significant, no? Yung may significant spikes. Now, sa modeling, guys, the more simple the model is, the better. Okay? Kaya hindi maganda kunyari yung napakalaki ng logs, no? That will not be a good model kasi masyadong complicated na siya. So parsimony, guys. The more simple the model, the better. Okay, tingnan nga natin. Let's use gamitin natin to, no? Dito para sa yung Arima model natin. Okay, so let's use, anong gusto niyo? Subukan natin Arima 2-2 muna, no? O sige, 3-2 muna. Ito ba yun? Hindi, MA2 eh. Asan yung ano natin? Bali. O sige, dito muna guys. Sorry ah. Ito. Yung sa MA model, tingnan natin, no? So, kasi dito, slow decay sa slow decay sa PACF, yung ACF natin yung may significant spike. So ito, ang guess natin talaga dito, MA1 to. No? Kasi remember, ang MA guys, ang moving average, ang ginagamit natin ng basis yung ACF. PACF, slow decay, ACF, significant spike, no? At 1. So we can say that this may be Arima 0-1, no? 0 yung AR, 1 yung ano. Of course, yung pangalan na to guys, bahala kayo. No? This is just a name, no? So I'll call yung M1 yung model natin, di ba? And the order should be 0, 0, 0, 1. 0, 0, 1. Okay? And then let's print the O1. Okay, so let's run this. Oops, ano nangyari? Ay, sorry. Naka-capital to. Yan. Okay, pause muna ako guys. See my MA1 here, ang coefficient niya 0.583, no? 0.58. Ano ba yung ginamit ko na na coefficient dito? 0.6. So, pretty close, no? So, nahulaan nga ni na model ng function natin na it's a point, ang coefficient natin 0.58. Pause muna ako. May questions kayo? Okay guys? Clear ba? Paki-chat naman, paki voice out kung clear so far. Hello? Okay ba? May questions? Clear? Okay, thank you. Okay, experiment lang tayo guys. What if, di ba alam natin na MA model to? Hindi pa natin plot na lang din natin guys yung copy natin yung copy na lang para mas mabilis. Control C. Copy natin yung Control V. So Arima 01 yung model natin. Let's check guys yung residuals, no? Let's check the residuals if okay yung model natin na Arima 01. So i-plot ko yung residuals. I'm sure na lang to na okay siya, na wala siyang trend, wala siyang seasonality. Okay, and then yung AC natin, let's see. Okay. Look at that guys, no? So white noise siya, no? So ibig sabihin okay yung model natin. Now, ang tanong ko, what if we modeled the MA1 process as AR1. Okay? Tingnan natin guys, ano mangyayari? Di ba si M1 natin, si M1 that's an MA series. Di ba? Kasi sinimulate natin yon. What if we model that as Control C? Okay, I'll just call it X, no? X na lang. I'm creating an object called X. Tapos Arima, si M1, imo-model ko siya as AR 1 0 0. Okay, and X. Okay, what am I doing here, guys? We're using the M1 time series. We know that that M1 series is MA kasi sinimulate nga natin yan, di ba? Okay? So pero, ang gagawin ko, imo-model ko siya as AR. Yan, AR1 to, no? AR1. So let's see what happens. Kung minodel natin siya, okay, lumalabas dito na AR1 0.441. Okay? 0.4. Ang AIC niya, AIC is 2923.37. Yung AIC kanina natin dito sa MA, pronounce ko na ba ito? 2825, no? 2825. So, yung MA1 process na, yung MA1 na time series natin, when we modeled it as M1, okay, ang lumalabas na MA coefficient is 0.58. Tapos ang akaiki niya, 28.25. But when we modeled it as an AR1 process, you notice that the AIC is higher. So ibig sabihin, kung yun lang pagpipilian natin, dapat yung MA1 ang gawin natin, no? But let's see guys yung yung residuals niya, no? So X residuals. Okay. Tingnan natin guys. Kasi minodel natin yung MA1 process na yan as an AR, no? Tingnan natin kung ano lalabas sa Okay, tingnan nyo guys. What happened to the residuals? Could anyone comment, guys? Can anyone comment on the residuals of the X model natin, no? Yung X model, let me repeat guys. Let me repeat, si X, minomodel natin si M1 na time series. Now, alam natin si M1 is an MA series, no? Kasi sinimulate natin yan, di ba? Nag-simulation tayo ng M1 model, right? Pero ngayon, minomodel natin siya as AR1 process. Okay? So first, may lumabas na na coefficient, no? 0.411 daw. Pero ang AIC niya 29.23, which is lower than the, as expected yan, lower siya than the MA1. Pero ang fruit of the food, ang ultimate test yan guys, yung residuals, tingnan natin. O yung residuals ba nito, white noise ba to? Ng AR1 model natin para dun sa M1 series. Can anyone please comment guys? Hello? Any comments, guys? Hello, hello, hello. Diyan pa ba kayo? Am I going too fast, guys? Ano na? Any questions? Hello. Okay, mukhang walang questions, no? So, ito guys, this is a bit more, saan yun? Saan yung simula nito? Okay, ito, we're creating a series, no? A series ng, ang nawala yung, ano may na-delete ako dito ah. Ito na lang titingnan natin ha. Parang may na-delete ako sa AR process ko dito. Okay, let's take a look guys at this, yung MA process, no? Here, nag-create ako ng apat na na coefficients, 0.7, 0.2, negative 0.1 at saka negative 0.3, no? Okay, so nag-create ako ng MA model, MA mods list, no? Ano yung list natin? Kukunin niya dito sa queue. Okay, this is your MAQ from 1 to 4. Tapos mag-Arima, magsa-simulate siya, okay, from 1 to Q. Ibig sabihin, ito gagawin niyang MA process, yung 0.2 gagawin niya, negative 0.1 at saka negative 0.3. In other words, guys, this is a good function in order to generate apat na MA. Apat na MA time series, no? Okay, and dito din ulit si Arima.sim. 1,000 yung sample size natin. So let's run this. Let's run that. Tapos i-plot natin. Okay. This will just plot, no? Partition natin yung 4 rows and 3 columns. Let's see what this gives us. Okay. Ito yung pinakita ko sa inyo, I think kahapon. Yan. Okay, take a look at this, guys. So this is a neat way to show all at once, no? Apat na MA series. MA1, MA2, MA3, MA4. Okay, let's take a look at the ACF and the PACF. Tingnan nyo guys yung spike at the ACF and then dito slow decay dito sa slow decay both positive and negative dito sa PACF. Spike again here, spike at lag 1 and then dito hindi siya masyadong apparent, parang spike din pero it looks like more of a slow decay din. So these are all MA series. Nakikita niyo yung yung mga spikes at the PACF and then sa ACF tapos sa PACF mga slow decay siya. Okay? So I hope clear yun guys na this just illustrates to us yung behavior ng MA. So nawala yata yung sa akin sa akin nawala yung AR ko kasi plot na to eh. I think na-delete ko yung okay, but I hope it's there with you. Yun yung plinat natin kahapon, no? Okay, magta-time na, let's see. Okay, ito guys, sana may I know guys kung na-introduce ko na sa inyo yung quant mode na package. Hindi sure kung dito sa section nyo or sa sa Ano nga, please, paki-confirm kung nag-quant mode tayo. Ay, no. Wala, sorry. Okay, so ito guys, just to show you, no, there's this package is very powerful in getting prices. For example, itong quant mode na package na to. Sa kabilang section guys, sa kabilang subject ko yung FinAnly, we were doing, pakita ko lang sa inyo, dito ko lang papakita, no? It's time guys, so let me just have 1 or 2 minutes. So here we're doing portfolio maximization and we're using the quant mode package to get stock prices. Kunyari, ito guys, I want to get from Yahoo Finance yung S&P 500. So that's very easy to run, no? So run ko to. Ayan, so andyan na yung S&P 500. Okay, if I pa-plot ko siya, no? Yan, okay? So you have the volume here, you have the S&P 500. Dinefine ko kasi kung kailan yung simula from December 31, 2016. No? Okay, so dito, in fact, pwede natin ma-zoom in yan. Okay, so this is a candlestick. Sa malamang na-meet nyo na yan sa ibang subject na candlestick chart. Okay, balik ulit ako dito guys, and then before we go. Now, kindly run this guys. Paki-aralin nyo to. So, ito, ida-download natin yung stock prices ni Apple from January 1, 2014. Gawin na lang natin tong December 21. December 31, 2021. Pakipalitan nyo na lang. Okay. When we run this, okay, bibigay sa atin yung prices ni Apple. Open, high, low, close, volume adjusted. Okay, so this is the quant mode package, guys. Very, very powerful package. Okay, so may I request you guys to please go through this. No? Go through this. Tapos ang gagawin natin, no? Okay, plotting to. Plot. Tapos ang ginagawa natin dito ngayon, ito guys, no? Kasi if you can see from the plot, no? Okay. Sorry. So andyan na si Apple, ano? Ang ginawa natin dito, kinuha lang natin yung closing prices and I gave it a name, small a. No? So dito, okay. Wait. Ito pala, pinalitan ko muna yung big A ng small a. Tapos kinuha ko lang yung last column. Yan guys, yung last column ito, no? So please use that, go through this process. Pinalitan ko lang yung pangalan niya. Yung column ginawa kong adjusted na ngayon. Okay? And then, dito plinat natin siya. Here you can see, yan, tingnan nyo. Oh, hindi siya stationary, no? Hindi siya stationary. So what do we do with this, guys? Hindi natin pwedeng magamit si Box Jenkins. So, guys, pakirun ito, tingnan nyo to ha. Dinifference ko siya. Yan, tingnan nyo. So, difference. So, ano nangyari sa difference, guys? Okay, take a look. Ang ginawa ng difference, guys, minus. Dati, 17.51, 7.14. Ang difference data na ngayon, minus na natin yung time t sa time t minus 1. Ito na sinasabi natin na difference. Ito na yung Arima, guys. No? Kasi dinifference natin siya. Okay, so dito, tinanggal ko lang yung first row. Okay? First row, guys. Kaya yung difference Apple, wala na yung NA dito. And then, yung modeling na sa baba. Okay? So next meeting, guys, ano lang natin ng sandali ito. Then we go to Garch. Okay, so that ends our discussion on time series. Okay? So isasama na rin natin yung testing, yung residuals, yung normality ng data natin. Okay? All right, so let me stop the recording now.